Hey everyone, welcome back. So in this video, let's clearly understand the transport layer in computer networks. So I'll keep it super simple and relatable. The first image, it is a mailroom in a company. So different letters they come in and the mailroom sorts them to the correct person. Similarly, the transport layer, it makes sure the data comes to the correct application and not just the device. You can see the network layer and the application layer, how they perform. And so this is called as the multitasking reality for the ports. So now think about your phone. So you use YouTube, WhatsApp, Instagram at the same time, right? So how does data go to the correct app? That's where the port numbers come in. Each app has its own port, like a room number. So the transport layer, it delivers data to the right room. So here I have given the host versus process delivery. So in the network layer, the message it goes to the correct building. So that is called as the IP address. But there's no specific recipe, and that means to whom it should deliver. But when it comes to the transport layer, here it navigates the internal structure and it hands the message to the specific running application, which means when you take your home as an example, the network layer is something where we place the order at the doorstep. But when it comes to the transport layer, it is something where we go into the specific room like kitchen, bedroom, hall, and then we go and place it there. So that's the difference between them. And then these are called as the addressing the process. So here how we do that. Here we have two different addresses. One is the IP address and the another one is the uh, socket address. So in between both we need the port number also. So IP address is nothing but to locate something in the host machine, to locate the host machine. So for example, if you are routing or giving some kind of data, then in the network, this IP address will be used to locate where or which one should we actually deliver the packets. And next, the port number is for the process identification, and then the socket address is nothing but the connection, which is unique to everything. Then this is the port ecosystem ICANN ranges. So here we have three different things, that is well-known, registered, and dynamic or private. So in well-known we'll be having like 0 to 1023, and in registered we'll be having like 1024 to 49,151, and in dynamic we'll be having like 49,152 to 65,535. So this is called as multiplexing. So multiplexing is nothing but bringing multiple processes into the network layer stream. So that is in simple words, it means combining the data from multiple apps and sending it together efficiently. And at the receiver end, it then again separates itself. So here encapsulation is nothing but we are wrapping the data payload, that is the actual data, in a header containing the socket address. And then comes the flow control. So here we are doing pushing and pulling. So pushing is nothing but where we send the data whenever it is ready, and pulling is nothing but the receiver requests, like I'm ready to receive, it requests, and then the delivery is done. So here the flow control is inherent. And this is the error control. So in error control, there are four pillars that is to be concentrated. One is the corruption, next one is the loss, next is duplication and ordering. So corruption means the packets which are not authenticated or which have some issues are being eliminated, and loss is nothing but tracking out which packets are missing. Duplication is if any of the packets has the same thing or it is being cloned, then it is removed. And in ordering, What we do is that we buffer out of the order packets to restore them in the sequence. And here comes the sequence number and sliding window. So here we have like first we acknowledge, then we send, then we wait for the acknowledgement if it is usable or if it is not sent, and then we do it for the future. Here comes the congestion control. Congestion is nothing but when two or many datas come during the same time. So congestion appears. So in such cases, we are in a situation to control the congestion by detecting the back pressure and voluntarily reducing the sending speed. And next one is the connectionless UDP. So here we go in for no handshake method, but it is unreliable. Even though it's unreliable, it is an instant transmission is being done and is very super fast. And TCP is a connection oriented, just the opposite of UDP. And these are the finite machine state machines. Here it is connection oriented. Uh, and the same way, it is first it is closed, then it waits, then establishes, again it closes, and then receives the acknowledgement and closes the process. So this is an overall summary that I have given, and you can go through it. So here are three types of connections or services: connectionless, connection oriented. So you can find it out. And these are some of the references that I have given.